Welcome to Lecture 16. Today we're going to talk about evolution in France in the early 19th century. I mentioned in the last lecture that Georges Cuvier had no use for ideas of transformism. That's what evolution was called in France in the first decade of the 19th century. I even suggested that part of his motivation for his theory about catastrophes was to oppose such notions. Transformism was way too speculative for Cuvier's tastes. He liked ideas that were closer to the empirical data of observation. At least that's how he thought of it. Whenever transformism came up, it reminded him of the old theorists of the earth. Cuvier made it clear that he far preferred the approach of Abraham Werner. He liked Werner's concern to stay close to the world we see, to build up our ideas slowly and carefully from there, not from some grand idea of a comet hitting the sun, beginning to cool. That kind of thing just didn't lend itself to observation at all, and Cuvier wanted none of it. Now, we learned last time about the world of prehistoric beasts that Cuvier introduced to the educated public of Paris during Napoleon's reign. He convinced a lot of people, at minimum certainly most French natural philosophers, that prehistoric beasts, the ones he described, were extinct. And he explained that they had been made that way because of violent catastrophes in the past that had wiped them out. He did all this in very dramatic fashion. He was good at giving public lectures. In fact, this whole subject had, during the first decade of the 19th century, contributed in a major way to Cuvier's rise to considerable fame and importance among French natural philosophers. Now, Cuvier had a senior colleague who fundamentally disagreed with him about prehistoric beasts. He was 25 years older than Cuvier, been a natural philosopher for a long time, well before the French Revolution, in fact. His name was Jean-Baptiste Lamarck, and he took up the cause against Cuvier's account of the history of life. Lamarck's story, it's a sad one in many ways. In this lecture, we're going to become familiar with that story, and in the process, we're going to learn about the evolutionary system for which Lamarck has become famous. Prior to the Revolution, Lamarck had acquired a respected place among French natural philosophers. In the old regime, he'd become a member of the circle of botanists and students at the Garden of the King, that venerable French institution of natural science we keep running into. Buffon was still the head of it when Lamarck was there. In fact, he took Lamarck under his wing. My own hunch is that Buffon sensed in the young Lamarck someone that reminded him of himself. I mean by that, someone who, like Buffon, was not afraid to speculate. We know Buffon didn't hesitate to hypothesize. His theory of the Earth was about as speculative as you can get, with its idea of the comet hitting the sun and all. I'm going to say more about Lamarck's speculative spirit in a minute, but first, let me say again that it was the speculative side of Buffon that Cuvier disliked. So as you might guess, there'll be trouble brewing when the speculative spirit of Lamarck clashes with the more empirically minded Cuvier. But I'd be seriously misleading you if I were to depict either Buffon or Lamarck as total dreamers. Both respected the need for close observational work in natural philosophy. We've noted the experimentation Buffon did on the cooling of various substances in support of his theory of the Earth, and he was, after all, the author of a multi-volume work, The Natural History, that cataloged a wealth of empirical information about the living world. It was just that he liked to combine or supplement this kind of careful observational work with grand ideas, with theory. And he didn't apologize for doing so. It was the same with Lamarck, too. He was 33 in the year 1777. That was when he completed a work on the flora of France that really impressed Buffon, something not that easy to do, but something definitely in Lamarck's interest to do. He was on the way up, and he needed the support of a well-placed, powerful figure among the French natural philosophers. Well, there was no one more well-placed or more powerful than Buffon at the time. When Buffon arranged to have Lamarck's work on the flora of France published, things were looking good indeed for Lamarck. In fact, it wasn't long before Buffon assisted Lamarck in getting a position in the botanical section of the Academy of Sciences. And then, in 1781, Buffon created a position for Lamarck at the Garden of the King. He would be a correspondent there. His rise in the world of French natural science appeared assured. And then came the Revolution. Buffon died in 1788, a year before the Revolution broke out, so he escaped what lay ahead for the institutions of natural science. You see, you began to hear the sentiment expressed as the Revolution progressed that maybe the pursuit of scientific knowledge by these elite natural philosophers wasn't all that compatible with the democratic spirit that was taking over. By 1791, there was a constitution, and it took away the old status of the king as a divinely anointed ruler of France. He was still king, but now, here's how it read when where the office of the king was concerned. He was now Louis, by the grace of God and the constitutional law of the state, King of France. That meant that the executive power now was answerable to a legislative assembly. And in another year or two, the democratic spirit grew even stronger. So strong that it outgrew the confines of the middle-class leaders who'd been trying to exploit it to gain advantages for themselves. The cry of liberty, equality, fraternity began to spread farther down into the third estate, woke up the urban workers to the realization that they weren't benefiting all that much from the revolution. As this happened, the revolution became more and more radical, and those in positions of traditional authority and privilege became more and more suspect. And these included the natural philosophers of the Academy of Sciences, the pensionnaires, the ones who separated themselves from others by virtue of their learning and erudition. But you have to realize that to many, they were just part of the elite establishment. They had privileges. Now, some of the members of the Academy realized they were in trouble. And in fact, there were those who were sympathetic to the idea that some change would be good. In fact, one of them, a man named Condorcet, he was the secretary of the Academy, he proposed a new national society in the spring of 1792 under the guise of educational reform. But it was just at the time when the revolution began to turn radical, and it didn't work. It took 8 months, but eventually the National Convention, that was the name given to the legislative body elected in the fall of 1792. The National Convention persuaded a sufficient number of members to oppose Condorcet's plan. They branded it a secret desire to retain citizens under the academic rod. In fact, the Academy of Sciences itself was doomed. The chemist Lavoisier, the architect of the new French chemistry we learned about in Lecture 6, he was at the height of his fame in France, and he tried desperately to save the Academy. But it was all for naught. The Academy, along incidentally with France's other learned societies, was eliminated by action of the convention on August 8, 1793. Regrettably, that wasn't all that was eliminated by the radical National Convention. Once the terror got underway, it took Lavoisier himself to the scaffold. Well, once the reign of terror passed and the violence subsided, the convention came up with yet another constitution in 1795. It took a more reasonable stance toward those older institutions it had earlier closed, and where the Academy was concerned, with good reason. It had become clear in fighting the war with the enemies of France, the foreign enemies of the Revolution, that men like Lavoisier and their research might be useful. For example, with France surrounded and imports impossible, might not these natural philosophers be helpful in discovering ways to produce gunpowder we need so badly? In any event, by 1795, it was decided to revive the Academy under new management. A national institute was created to replace the old Academy, but it added some new sections to the old structure. For example, it included sections for moral science and for literature and the arts. The old Garden of the King had already become the Museum of Natural History, and several other new institutions were also created. Now, Lamarck's status had risen high enough before the Revolution that he came out pretty well in the reorganization, at first. For example, he was given a chair in the new museum, and he became a member of the scientific section of the new institute. But it would soon all begin to go sour. And the main reason why was that Lamarck began to realize that he harbored some fundamental disagreements with many of his colleagues. Basic kinds of disagreements. This wasn't just a matter of disagreeing about this or that individual issue. It was a matter of approach. It was a disagreement about how one was to do natural philosophy. I've indicated on a number of occasions that this was the period when the very meaning of what it meant to be scientific was being contested. We examined alternative visions of natural science in Germany. Here in France, we have another version of the debate about the proper way to proceed as natural philosophers, but in this debate, Lamarck clearly was made to feel part of a minority. Well, as I said, it began to go awry for Lamarck already in the mid-1790s. There were glimmerings of some dissatisfaction from his colleagues around the time of the reorganization of the Garden of the King and the Academy. Certainly nothing significant enough to stand in his way, that is, of his way of becoming part of the new organizations, but some murmurings nonetheless. The reason was Lamarck had published a book in 1794, and it was different from his earlier publications, and his colleagues began to take notice. His earlier work was distinguished by its exhaustive detail. Everyone knew Lamarck was an expert on botany and the flora of France, and he would continue this kind of work in another field as well. As part of the reorganization of the Garden of the King, Lamarck had had to switch fields to invertebrate zoology. In this capacity, he began compiling a series of publications that would be consulted for many years in the future. Charles Darwin, for example, went straight to them many years later when he had a question that he knew Lamarck could help him with. So Lamarck continued on his empirical work. Anyway, one side of Lamarck reveled in this kind of close work. But there was another side, the side that appreciated speculation and theory. And that was what was in this book of 1794. Now, I don't want to spend time on this book. All I want to emphasize is that it showed this other side of Lamarck clearly. You could tell that from his title. It was one of those long 18th century titles, and it was very revealing. It began something like Studies of the Causes of the Principal Physical Facts, and then rambled on for a full paragraph about everything that would be included. And that was just about everything. He promised to cover physics, chemistry, and physiology, all in one book. And with what aim? To uncover the causes of the principal physical facts. That's pretty bold. This was exactly the kind of theorizing about grand causes that many had little patience for. And they began to say so. By the early 1800s, Lamarck, who didn't apologize for this other side of his interests, found that relationships with his colleagues had suffered, and they would continue to degenerate as Lamarck's interests and ideas on evolution, which were increasingly present in his work after 1800, were regarded as more evidence of this spirit of system, as it was known. It wasn't long before Lamarck himself began to feel somewhat ostracized from the group of natural philosophers working in Paris. I think it's safe to say that his career trajectory, which earlier had been fine, now had been altered. He was still a senior colleague who had done respected work, so you treated him with respect in public. But what was this other side of him? Good question. The fact is that Lamarck's account of life's past was among the first systematic expositions of evolution. We know it reflected the speculative side of his disposition, but where specifically had that come from? What was his incentive to move in this direction? I think there are several components to his motivation. First and foremost, of course, evolution was Lamarck's way of adding up the observations of the living world. I'll show you how he did this in a minute. Beyond that, I think he disliked what the young upstart Georges Cuvier was saying about extinct prehistoric beasts. And it must have goaded him a little bit, maybe a lot, that Cuvier was so popular with the French public. Well, what specifically was it that he didn't like about Cuvier's theory? It was Cuvier's reliance on catastrophes. Lamarck, you see, believed in a well-ordered universe. He was very 18th century in this. One of the ways Lamarck's well-ordered universe showed itself for him was in the wonderful balances that function to keep nature in equilibrium. Again, a very 18th century notion. And something completely incompatible with this in his mind was the possibility that nature could get so far out of whack that a whole species could become extinct. That was just too much of a disruption of nature's order, something her wisdom would not permit. And of course, how did Cuvier explain extinction? Through major disruptions in nature's equilibrium, through catastrophes, singular events that came out of nowhere and didn't seem part of nature's normal steady course. Lamarck said these interventions of Cuvier's were, and this was his phrase, too convenient. They weren't part of the regular order he believed nature followed. But wait a minute here. Am I saying that Lamarck rejected Cuvier's prehistoric beasts? And if he didn't, what did he think they were? Lamarck certainly acknowledged the reality of the fossils as remains of animals that had lived in the past. But he didn't view them at all like Cuvier did. Now, get ready to think in a different mode. Lamarck argued that Cuvier's older species still existed. Not literally, that is, you couldn't go out and find a mastodon somewhere today, but they still did exist. Let me explain. As I said, Lamarck didn't believe in extinction. That was just not reasonable. How could you get a whole species gone? What kind of power would do that? These older species had not become extinct. They had just changed over time. These past species still existed in the form of present species. Present species, in other words, were past species that had changed. So Lamarck didn't regard past species as lost just because they had merely been modified by time. Now, the difference might sound trivial to you or me. It wasn't trivial to Lamarck. Catastrophism was not good natural philosophy in his view. We need to appeal to causes that are regular and law-like, and extinction, through catastrophes, didn't fit that bill. Now, I suppose you can see that an evolutionary view is implied by Lamarck's objection to catastrophes. The prehistoric beasts are earlier forms of present species, so obviously they must have evolved into their present form. Many of Lamarck's ideas on this evolutionary development were in place by 1802, but they would not appear in their full-blown form until 1809 when he published his book, Zoological Philosophy. We need to spend some time with this book because Lamarck's ideas on evolution would prove to have great staying power in Western culture. Lamarckian ideas would keep coming up over and over again in both the 19th and 20th centuries. So we need to know what he said about evolution. Lamarckian evolution began with something he called the power of life. This was an expression of a capacity that living things possessed simply because they were alive. It was not something that inorganic things shared, and it wasn't something that could be deduced from the merely physical constitution of living things. It was part of this new vision about life I mentioned back in Lecture 13. In fact, Lamarck was one of those four thinkers who independently coined the word biology, biologie for him, at the beginning of the 19th century. Anyway, Lamarck believed that as a consequence simply of being alive, living things become more complex. That was the power of life, the natural tendency for the organization of living things to become more complex over time. It was an especially important factor for the simplest forms of life and for plants where there's no nervous system. Of course, we see living things become more complex as they grow, and that was part of it, growth. But the power of life also manifested itself in another way. Inside living organisms, there was a constant movement of internal fluids, and these fluids exerted a continual pressure on the internal structure of living things. I think he almost was envisioning a situation like you see in geological development, when rivers carve out new channels as they flow. Here inside the organism, the movement of fluids carves out new channels too, and that increases the complexity by gradually altering the organization. So over time, the organization of organisms changes by becoming more complex due to the power of life. One matter I haven't mentioned yet is whether Lamarck said anything about how life got started. In fact, he did have a position here. He took his cue from the discussions about electricity's link to life we discussed in Lecture 12. Lamarck asserted that the simplest forms of animal and plant life originated by spontaneous generation. So the simplest plants and the simplest animals each came about as the result of spontaneous generation. Where did the electricity come in? Well, the electricity came in because, he said, spontaneous generation results from the combined action of heat, light, electricity, and moisture. Okay, so far we have simple plant and animal life as the result of spontaneous generation. And we know that as those simple life forms continue to exist, they'll become more complex because of the power of life. But their development over time is also affected by another kind of factor, and it comes about as a result of the organism's interactions with the environment over time. That also influenced the way forms of life developed. And when I say that, I mean both the individual organism, as it developed over its lifetime, and the species to which the organism belonged, as it developed over time. Let's unpack this other environmental factor. Lamarck asked, what happens when the environment in which a population of organisms lived changes? Well, he said, if the environment changes, then it follows that the needs of the life forms living in the environment would also change. Let's take animals, for example. Say the environment changes where a population of animals exists. To survive in the new environment, the animals would have to satisfy the needs that were introduced by the environmental change. As this situation settles in and becomes relatively permanent, the animals would form habits that would address these new needs. Now, I have to emphasize that Lamarck was being thoroughly mechanistic here. The animals' reactions to the changed environment were not the result of their exercising their voluntary will in the old sense of voluntary will. No, it was automatic, a simple matter of stimulus-response reaction. Environment changes, that's the stimulus. New habits, that's the reaction. No thinking needed. We could be as easily talking about plants as we are about animals. Okay, now here is where it gets very interesting. Let's suppose that these new habits mean that the animal makes use of one of its parts differently from the way it has used it in the past. Maybe it has to use it more than before the environment changed. Or it could be that it uses it less now than it used to. One or the other. Lamarck said that if it was the former situation, if it used the part more, then it would gradually strengthen that part and enlarge it. If it was the other case, when it used the part less, then that part would become weakened and gradually wither. Lamarck called this phenomenon the law of use and disuse. This was the gradual strengthening and enlarging or weakening and shrinking of an organ over time due to repeated use or permanent disuse. His most famous example of it was the giraffe. He noted that the environment in which the giraffe lived caused it to develop the permanent habit of constantly stretching its neck to reach the leaves of the trees on which it fed. The lowest leaves of the acacia trees are quite a bit off the ground, so to get to them, the giraffes have to stretch to reach them. When they'd eaten the lowest leaves, they had to keep on stretching to get the ones higher up. The result of this constant stretching of its neck resulted in the giraffe lengthening its neck slightly over its lifetime. Now, all this is nice, and it helps us to see how an organism could acquire a new characteristic during its lifetime, but how does it affect the species? That's where another of Lamarck's laws comes in, the law of the inheritance of acquired characteristics. This was the passing down of the traits acquired through use and disuse to the next generation. Lamarck said that these changes in bodily parts that are produced by use and disuse were passed down to the offspring of the organism that acquired them. They were inherited by the next generation. He was careful to say that the changes had to be common to the whole population. In other words, this isn't something that just affects a random organism here and there. It has to be something that all the organisms in the region experience. So, for example, take our case of the giraffe. When the giraffe slightly elongated its neck over its lifetime through constant stretching for leaves, that slightly longer neck was passed on to its offspring. And that length became the standard length for the next generation. But what would the giraffes in the next generation do? They would continue to stretch for leaves, just like their parents had. And that would mean that they would continue to elongate the standard neck length. This is the way the characteristics of the species itself were affected. This is how, over many, many generations, the giraffe had evolved an elongated neck. Pretty cool, huh? Makes sense. Now, Lamarck was hardly alone in thinking that acquired characteristics could be inherited. Lots of folks accepted that idea. When you combine the inheritance of acquired characteristics with use and disuse, it made sense. And if you threw in the power of life as well, you had to admire Lamarck's grand scheme for its creativeness. Well, is that how it was received? Admiration? What do you think? Alas, no. Lamarck's ideas were only appreciated by some. The friend from Cuvier's early days in Paris, Geoffroy Saint-Hilaire, he admired aspects of Lamarck's theory, but I must report that for the most part, Lamarck's work was relatively ignored by those who seemed to matter, or it was opposed. Evolution was too speculative an idea for some. After all, how could you go about testing it? How could you prove it? It was like Buffon's old idea about the comet and the sun. Nice idea, but not worth too much other than as an intellectual exercise. We'll never know if the sun was struck by a comet. Such ideas don't lend themselves to verification. So it was the speculative dimension of the work that confirmed for some that Lamarck was up to his old tricks. It was that dreamy side of him that natural philosophers should stay away from. You won't be shocked when I tell you that Cuvier and other opponents of transformism criticized the book. Cuvier respected what his senior colleague had done in botany and also respected his work in invertebrate zoology. It was Lamarck's transformism, or evolution, that he couldn't stand. And being the arrogant man he was, Cuvier wasn't above having some fun at Lamarck's expense. In his book on fossil bones of 1812, Cuvier mocked those who taught that hens near the water's edge could become storks. Now, I don't want to give you the impression that everyone went along with Cuvier's view of the matter. Later, in the 1820s, Lamarck's evolutionary ideas were appreciated within limited circles in France. But with a man like Cuvier against you, one of the most powerful natural philosophers in Restoration France, your theory had little hope of ever receiving the kind of recognition that Lamarck craved for it. Elsewhere, things weren't all that different. In England and Germany, there were a few individuals who found Lamarck's evolutionary ideas intriguing, some well-known people at that. But for the most part, Lamarck's influence as an evolutionist would not be felt until much later in the 19th century. Was it just the kind of reasons Cuvier gave in his critique that explains Lamarck's failure to win over his colleagues? I think there's more to it than just that. I think the reaction against Lamarck was also due to his extension of deism to include the living world. Let me remind you about deism. That's the idea about God's relationship to nature that we met so often in the 18th century. It suggested that God created the physical universe and the laws that govern it, and that these laws then produced what exists. And they continue to produce what will come next. In this scheme, God doesn't need to hang around to supervise. The laws God created take care of everything. Well, Lamarck's account certainly was deistic. Even the appearance of life resulted from the operation of natural laws. He didn't even acknowledge a direct role for a divine spark. Yeah, there was a spark, but it was a spark of electricity. And once life was here, its development, its evolution, also followed automatically as the result of the operation of natural laws. Remember, deists were not atheists. Lamarck believed in God. He just thought that God had created, as he put it, an order of things that on its own produced the diversity of living things we see today. Let me use a computer analogy again, as I did back in an earlier lecture. Here, it was as if God had created the hardware of the universe, installed in it an operating system of natural law, and then wrote a software program that expressed his divine intent for the historical evolution of living things. Then God stepped back, loaded the software into the universe, and hit the return key. Once underway, the program ran flawlessly by itself. No bugs in a deism or in a deist's divine program. God didn't need to hang around to govern evolution either. This kind of idea not only offended the average person who objected to its challenge to the Genesis account because of all the time it must require, Lamarck's deism was also too much for a man like Cuvier. He wasn't conventionally religious, but he couldn't go along with making God that irrelevant. In the next lecture, we'll explore what was going on in England during the same years that Cuvier and Lamarck were attempting to shape French natural philosophy.